Okay, so he's a Dutch former professor of social psychology at Tilburg University. He was born in 1966. In 1991, he has received his MA in psychology and communication in the University of Amsterdam. Later on, after he has received his PhD on the same University of Amsterdam. In 2000, he became a professor at University of Groningen. Then 6 years later, after being there, he has moved to the Tilburg University, where he founded his TIPER, which is an institute for behavior economic research. And 3 years later, he has received the Career Trajectory Award from the Society Experimental Social Psychology. And in 2010, he has become the dean of the Social and Behavioral Science faculty in the Tilburg University. Years later, I will go in more details in a second. He has returned his PhD title to the University of Amsterdam, and he was suspended from the University of Tilburg University. And in 2019, he has in total 58 publications that was retracted. So he was known for scientific misconduct. And okay, so after in the Tilburg University suspended him for being fabrication his data that he used in his research publication, the university needed to do further investigation of his work. And in the end of October, after doing stuff like that, they also found that his research misconduct committed was very vast, and they think that it goes back to at least 2004, which he already was involved with manipulation of data and complete fabrication of entire experiments. So he was famous, and just one of the Sadan, was transformed from being a respected professor to perhaps the biggest conman in academic science. How did this all start? This is a short summary. I will just make a bigger one. Okay, so stable. Hide.
You need the. Oh, okay. Sorry.
Okay. So, Stable was an academic star in Netherlands and abroad. The author has several well-regarded studies on human attitudes and behavior. In that spring, when the university has announced him that he's been suspended, he has published just then a widely publicized study in Science about an experiment that he done at the Utrecht train station, showing that the trash-filled environment tended to bring out racist tendencies in individuals. So after the university has informed him that he's been suspended, immediately he drove to the University of Groningen, where he was a professor there for 6 years. He went there to defend himself. He needed to know what story he needed to tell them if they ask him anything. So he needed further more details about the place that he claimed that he collected the data there. So when he arrived there, everything was different because it was 5 years ago already. But there was a building of a computer center where he decided to tell them that he did all his experiments there. And this is what he decided to tell them with the undergraduate volunteers. So, and in his way back from Groningen, he was stopped at the train station in the Utrecht, where he just recently, in spring, published his article that he claimed that he was studied and performed in the Utrecht train station. He went there because he needed to know more further details to know what the place is, because he didn't perform his experiment there. So he, as he is described in the science paper, while volunteers were invited to fill out a questionnaire in a seat among a row of 6 chairs, the row was empty except for the first chair, which was taken by a black occupant or a white one. So Stable waited there and tried to just to look for a specific location that matched his description and the conditions described in his experiment, but sadly he couldn't find anything that was related to the details that he has mentioned in his article. So, but just at that moment he realized that he needed to just give up. So let's go back in time when he was the professor of at the Groningen University in 2000. This is where he started to do his faking and manipulation data. He wanted to test the idea that priming could affect people without their being aware of it. So he did multiple experiments, and what he did in this experiment, that he needed subjects sitting in front of a computer, and he showed them a word or an image for about 1 till 10 seconds, and without make the participants not to remember the images and just to be in conscious minds. So the subject after that tested him on to determine if the priming had an effect or not. So in this particular experiment, Strabel asked the subjects to rate their individual attractiveness to themselves after they were flashed in an image of either an attractive female face or a very unattractive one. So his hypothesis that the subject exposed to the attractive image would rate themselves much less than attractive than the other subject that exposed to other images or to the unattractive ones. So things didn't went as he thought, and he didn't get the result that he desired. So he thought that he just have 2 chances, or either just to give up and just abandon this whole work, or maybe just do the experiment and maybe he will get better results with different participants. But he has already put a lot of effort in this and spent a lot of time. So he was so convinced that his hypothesis is so valid and is so true and it's already proven. So he decided for the first time just to fake and to create the data set. He just started to change the numbers into his laptop, and he put some effort to do that because he didn't want to get a very large significant effect, because it will be suspicious and they maybe won't believe his results. So he changed a little and just aimed to receive just a small significant effect. And after that, after he aimed and achieved what he wanted, he felt both terrible and relieved, because this was the first time that he's faking his data, and relieved because now he can publish his article and things will go as he wanted and desired.
So his statement that he felt terrible and relieved, that's something that later he admitted to? Or?
Yeah, he wrote a book. So I took some stuff from there. So, and the results were published in the Journal of Personality and Social Psychology in 2004. And this was the beginning of his manipulating and faking his data. So after that, Stable's careers took off, and he was publishing more than 24 studies while at Göttingen, and many of them written with his doctoral students. In September 2010, he became the dean of the School of Social and Behavioral Sciences. And by then, when he became the dean, he could just give this thing up and retreat from active research and just being the focus on the administration. But he couldn't do that. He couldn't resist the allure of fabricating the new results. He described this as being addicted to doing these doings. And Stable designed one such study to test whether individuals are inclined to consume more when primed with the idea of capitalism. To do this, he wanted to do this research with co-authors, and they developed a questionnaire that the subject would have to fill out under two different conditions. The first condition was there's a mug filled with M&Ms, and it printed on capitalism in this language. And on the other hand, the second conditions were also a mug that filled with M&Ms, but would be with different words. It would be a jumble of letters in capitalism, but not the same, not capitalism. So, and their aim was to check the amount that will be eaten of M&Ms by the subject while answering these questions. And the hypothesis that subjects facing a mug printed with capitalism would end up eating more M&M. So what he did, Stable had asked his student to arrange him to get the mugs, the M&Ms, and and to load them in his car along with a box of questionnaires. So he drove off, and he didn't went. He told them that he is going to the school, to high school in Rotterdam, where he know a friend that he will just do his experiment there and the student there. But this wasn't the case. He just dumped the questionnaires and trash outside of the campus. And at home, he just waited. He took a scale, he weighted the mug, and he started eating while doing filling out the questionnaire. And he believed that he can just know how much will consume a reasonable amount of M&Ms while answering the questionnaire, as the subject could have doing that. So he was the only subject here in this study, and this, but for some reason, his wasn't published in the end of the case. Yeah, but this didn't stop him from continuing what he was doing. There's a colleague from at Tilburg University, Ed Winkhurst, who asked him to help him with designing a study, and his idea was to whether exposure to someone crying affect empathy. So what did they plan to do? That just give an elementary school children a coloring task in which half of the kids would ask to color unexpressive cartoon characters, while the other half will color the same character but shedding tears. And after doing this tag, the children would receive candy, then ask the children if they are willing to share the candy with other children. And so Stable told him that he wanted to run and perform this study at the university, at the high school, where he do have contacts and usually do his research there alone. And a few weeks later, he showed to Winkhurst and showed him the result in just a sheet of paper. So Winkhurst, when he saw the result, he was delighted and happy because they got a significant difference between the two conditions, indicating that children exposed to teary-eyed picture were much more willing to share candies. So after that, Vinegar told him that they can now write they can write the story and it will be published, it will be a fuss and stuff like that. And he began writing the paper, but he wondered if the data that has shown already, if there's any difference between the boys and the girls. So he wanted to check that. He requested to see the data, but Stable told him that the data is not in the laptop yet. So Vinkers was shocked and stumped because how Stable showed him already the means and the standard deviation and even a statistical index attesting to the reliability of the questionnaire, which would have been needed a computer, but he didn't have it so far. So Fingers wondered if Stable, the dean, was somehow just checking him, testing him, or he also started to suspect fraud. And he consulted this case with a retired professor to figure out what to do. But the professor told him that he is the dean and he can't do that. And it's and so he didn't did anything, and he decided not to revert this case to the rector because he thought it's just his thoughts. It's not what he is thinking of. It's not a fraud case. So, but rumors of fraud trailed Stable from Groningen to Tilburg, but none of this raised enough suspicion to prompt investigation. Even thought always Stable did performed at the high school where he claimed that he's doing his experiment there alone and no one was allowed to go with him or to see the data. But nothing of this arose or was questioned by anyone in the university. And after that, in spring of 2010, a graduate student noticed anomalies in 3 experiments that Stable had run for him. So he wanted to check and ask the Stable to see the raw data, but Stable initially said that he has no longer the raw data. Later on that year, there was a new professor, a young one. So this student has became to him and mentioned his concern about Stable being misconduct with his research and being manipulating with the data. The professor decided, because he had also another students that he told spoken to him privately also, so he decided to just to get in touch with the Stables and maybe just attend his lab meeting and to see what's going on there. And he was struck and announced how great their data looked. They're always been perfect, and no matter the experiment was, they always didn't have any failure percent. They always succeeded, and they has always a significant and really significant effects. So the professor decided to approach to Stable just to get a closer up view and to see from a close view how he's working in his lab and what he's doing. So the two of them teamed up and designed a study to test the premise that reminding people of the financial crisis makes them more likely to act generously. So Stable told him that he would run as usual, he would run alone the experiment, and he will just later on inform him with the results. And after he had run the study, he told him and showed him a statistical relationship between awareness of the financial crisis and generosity. But when the professor looked at the data, he discovered inconsistencies with his results, which has confirmed his suspicions that Stable was engaging in fraud. So he didn't know what to know because he's young and he's new. So he consulted with a senior colleague in the United States who told him he shouldn't feel any obligation to report him. So he didn't report him and didn't do anything. But the person who alerted him to the student, along with another graduate student, refused to let it go. So what was done here, the other graduate student examined a number of data that Stable had supplied to students and postdocs in recent years. And she found that there a host of anomalies in which Stable appeared to have just copy and paste his job, leaving 2 rows of data nearly identical to each other in more just one study. So the 2 students decided to report this charge to the department head, to the Marcel Zillenberg, where Zillenberg also report him to the rector of the university. When by then he was suspended from university being there. And he was the first retracted paper was about coping with chaos. And it was his first retracted paper, but not the least. And this was done at December 2012, where his, after the university have found evidence of fraud in Stable's work, Stable has retracted his paper, and the co-worker with him was not involved with the fraud case. So after that, so to sum that up, so Stable was always just making up his result, not taking anyone with him, just doing everything alone, and he was the only one that was responsible of everything. And it became widely known that Stable treated his graduate student unfairly, with most of them graduating without ever actually doing or completing any experiment. So Stable controlled all the time the data in his lab. And when the students asked to see the raw data, they were often giving excuses.
So this hybrid thing when people join late is not ideal. Okay, are you finishing?
Yeah, almost finished. Okay, so the prosecution settlement was that he needed to perform 120 hours of community service and to lose the right to do some benefits associated with his former job, which equivalent to a year and a half of his worth of salary. So the question that arises here that what type of academic culture that allows Stable to continue this his misconduct for so long, from since 2004 till 2012. So it was 2 factors, because he was responsible for everything, and he just claimed that he's doing his research in secondary school because the students were just naive and therefore better research participants. And Stable was described as intimidating and not tolerant questions from students regarding his refusal to have them involved in the data collection. And it was the second, and also it was a number of red flags that the university need to do, but they haven't looked and cared. The colleagues weren't aware that the doctoral students didn't collect their own data. It's just he's written his name. So Stable, he published, and a year later he published his book, and he told everything about his emotional and how he became like that, because at the beginning he didn't needed to pee to use the manipulation, but he described himself as someone with elegance and order, that he need to something, and someone who achieved always to have perfect results and be the shining one. So this has led him to do this.
Very much. So, okay. Comments?
What happened to the students?
They didn't retract their doctoral thesis, or it's just because they have investigated the case. No one was involved with this case, just Stable by himself.
The degrees were signed on wrong papers.
Yeah, but how can they have a degree?
He was collecting the data and giving it to them. Maybe they wrote their analysis and stuff like that. But the raw data, they couldn't take it. But furthermore, when they needed to do more the analysis, so they did it by themselves.
So you can cheat some people some of the time. You can cheat some people. Not cheated all people. I'm sure that counts. All right. And by the way, the excuses sound exactly like Sean. Right?
He wasn't punished. 1.5 years salary. He made 20. Relative to what he
But
made.
he was like, but he I think he punished himself. He punished himself.
He made how much money off of those books? I mean, and how much can you like say like, oh, I feel so bad, I feel so terrible, but he went on for years fabricating research, literally doing nothing. How is that like?
Yeah, but
But he's a celebrity. You can make money of writing.
yeah, he sounded like it. But I think also like he punished himself because he was depressed, and this what I wrote, like I'm not feeling sorry for him, but like he also aware of his doing, and he's regret that. It's like there's no way back to what he did. But also everyone who was living in his city and stuff like that, everyone knows his case. So he was so shamed. Yeah. No, he claimed that he wanted to learn from him because
That's what rehabilitation.
Because when he started to fake his results, he didn't thought that he will get that far, but he got addicted to it.
It's very hard to stop.
Yeah.
Thank you.
All right. And by the way, I think it's really quite amazing that we see this type of frauds in physics, in psychology, in every field. You find people doing this. Okay, so Hannah, and actually it would be better if you can somehow be captured by the camera, and then people can see you.
Okay. Nice to see everyone today. Okay, so today I'm going to tell a story that's a little bit different than the scientific misconduct stories that we've heard so far. It's actually a story about one of the greatest scientific discoveries, if you can say. It changed the world for the better. So the story is actually about Henrietta Lacks. Does anyone know who she is? Just curious. You know? Okay, so yeah. So it's crazy. There's only one person in the room that's even familiar with them. Okay. And if anyone has any questions or like nothing or something's like not clear, just ask. So the story, like I said, is about Henrietta Lacks, her immortal cells, and informed consent. Yeah. So as I'm going through the PowerPoint, just these are like the discussion questions that I would put actually before, so think about them during, and that's should patients or donors be compensated for biological samples, and should samples in biobanks taken prior to the declaration for Helsinki be compensated for the living family members retroactively. If that doesn't make sense, don't worry, you'll understand it by the end, but keep that in mind. So if you're here sitting in this room right now, you have benefited from HeLa cells. They have been a part of, the colors are different on the, that's okay.
All right.
No, it's even nicer.
Are you going to tell us what the acronym for HeLa or everybody?
Oh yeah, where it's a story.
It's a
story.
story.
Okay, so they've been a part of many different scientific discoveries. I saw a statistic, and if you search on PubMed HeLa cells, it's over 116,000 publications. Polio vaccine is here because of HeLa cells. You have AIDS research, the HPV vaccine, tuberculosis, COVID-19 research, also modern day research. A fun fact is they have been in space to test zero gravity on human cells. Okay. Did it switch? Okay. Okay, so I don't know how many of us are really biologists here, but there's a couple basics of cell culture just to understand. It's very straightforward though. Basically, you have two different types of cell lines. The first, and they're differentiated based on their origin. So primary cell lines come directly from a donor. That could be a plant or an animal or even a human. And the second type of cell line is secondary cell lines or immortal cell lines. Those come from cell stocks. Those are cells that have been multiplying for generations. Once you have your cells from whatever origin that you have, they go through pretty much the same process. They're grown in media that provides nutrition for the cells. They're placed in an incubator at a very specific temperature and humidity. When they reach almost full capacity, whether that's on a plate, adhered to a plate, or in solution and suspended in solution, then it's time to passage them, which would be taking part of the cells, moving them to a brand new flask with new media or to a new plate with new media, and letting them reach again to almost full capacity. You can go ahead and do your experiment, or you can keep the cells for maintenance. Primary cells end here. They're not really passaged more than 5 times. The cell stocks, or the continuous cell lines, which is what we're talking about today, those are infinity. Those you can freeze, they can kind of put it in a dormant stage so that they don't continue multiplying, or just keep them for maintenance in the lab. So because we're talking about history here, let's go over a little bit about cell culture history. Who knew there was such a thing? But in 1885, this is the first time that we saw living cells grown outside of the body. In this case, it was a chick embryo, which I actually did in my first degree. We took a egg, hatched it onto a plate. And honestly, I think we kept it alive for like 14 days. In 1885, they were able to do that too. In saline buffer, they kept them alive. Then in 1907 to 1910-ish, we have Ross Harrison. He made a couple discoveries. Most importantly, as someone that works with cells, is his introduction of aseptic techniques to cell lines. If you've worked with cells, you know how frustrating it can be for the risk of contamination. So it's really important when you're working with cells to always work in a completely sterile environment, or as sterile as it can be. All right, 1948, we're jumping. We have the first continuous cell line, but these are from mouse cells. Nonetheless, it's a great discovery. Things start rolling in the cell culture field. These were mice fibroblast cells. They were called L929. And now, finally, we're at our point in history, 1951, the discovery of HeLa cells. HeLa cells, cultured by the scientist Dr. George Gay from Johns Hopkins. These cells are monumentous because they are the first human cell cultured, continuous cell line cultured outside of the human body. They come from an adenocarcinoma, so they're cancerous cells. I will note in history that it was only a decade later, 1961, that there's the first human cell line that's from normal, healthy cell. And that was a decade later. So this is really, monumentous, and it's monumentous for a good amount of time, being like the only cell line, continuous cell line on the market.
So these are specific type of cells, not just any cell from the human body, right?
No, and that's how we work with cell lines. So there's, specific cell lines, and
it makes sense that it's cancer cells are easier in cell because cancer cells are kind of immortal and they divide all the time.
Yeah, it plays with the physiology of cancer that they quote that it's because of the elongated telomerase enzyme. So that's what keeps them. They have an advantage over other cells. Nonetheless, right place, right time, right scientist. They were able to get these going.
Even on plate, even on plate.
Yeah, and they're in plates, not suspension. Okay. Actually, and then 1961, those cells, that's also a story that if you're interested, I would be interested in reading about it too. So, okay, moving on. So who was Henrietta Lacks? Here we're finally answering our question. Henrietta Lacks, the HE and the LA is the HeLa abbreviation. She was born on August 1st, 1920 in Roanoke, Virginia. That's in the southern part of the United States. Her nickname was Henny. She was a mother to 5 children. She was diagnosed with cervical cancer and died shortly later in 1951. cells from her tumor were taken without her consent and given to Dr. George Gay, who cultivated the first human cell line.
Her cell are still living, right?
Of course. Yeah. Okay. So I don't.
She, in fact, she yes.
That's what they say. Immortal, and they also call secondary cell lines immortal cell lines, and that's like the. So think of your no one can put themselves in their shoes, but think she's a Black woman. First of all, I don't know if I made that clear. She was a Black woman in Southern United States from 1920 to 1950. She had a difficult upbringing. She was one of 10 siblings. When she was 4 years old, her mother died, and she went to live from Virginia. She was moved to Clover, Virginia, nearby, but also in the Southern United States. She worked on a tobacco farm. She went to school until 6th grade, and then she was made to drop out. She had to help the family. Pretty typical of that time period. And again, I grew up in the States. I did study American history and civil rights. But if you're not familiar, the US at this time, segregation existed legally. That meant discrimination. It was all legal, mandated by states, not federal law. And that was until 1965. It was called the Jim Crow era, if anyone heard. That meant that whites and Blacks couldn't go to the same schools. They couldn't eat at the same restaurants. They couldn't go on the same public transportation. And if they did, Blacks sat in the back or they stood. Even they couldn't even interact. It was really a difficult period of time. Even though slavery was abolished, it still very much existed. That, of course, translates to their medical care. If they received any medical care during that time, that's a picture of Johns Hopkins. If anyone knows, it's pretty famous as far as a hospital and a university.
I was there 2 weeks ago.
So, so yeah, historically, Black patients received little to no healthcare in the U.S. As segregation goes, if they did receive healthcare, obviously it was segregated. It wasn't in the same hospitals, or if it was in the same hospitals, Johns Hopkins was a hospital at the time, one of the only in the area providing care to Black patients. And I found a statistic from 2017 that even nowadays, the disparities between the life expectancies of Blacks and whites still very much exists. In Chicago, it's a 16-year difference, and New York, it's a 10-year difference. And okay, you see the quote on the bottom. Huh? This is actually in life expectancy, which actually that's a point. I mean, there's obviously so many factors that go into that. It's a result of systemic racism in the United States. So, it's not just medical care, but it should be noted. I think it's important to the story. And the quote that I found, it's pretty faded there, but just for everyone to understand, racism in America, being Black isn't just about being singled out for a particular fate. It's about a disproportionate chance that you will suffer a particular fate. Sorry, I can't even read it here. But. Okay, so here's her story. And it's actually a book. I read it in high school biology class, where at the end of the year we had time. Henrietta gave birth to her last child in November of 1950. 1951, Henrietta complained of a knot in her womb, and her physician at Johns Hopkins took a biopsy from her cervix. She was then diagnosed with epidermoid carcinoma, which later on they found out that it was actually an adenocarcinoma. She was then treated with radium tube inserts, and at checkups, tissue was then taken from healthy and cancerous tissue, and it was sent to our research scientist, Dr. George Gay, and this was all done without Henrietta's consent to taking the samples or for knowing what they were even going towards. And I want to point out at this point, nothing in the story is out of the ordinary. For this time, the only thing that has changed nowadays is that informed consent is a thing. But at this time, the difference between her healthcare between, say, a white woman at the time, there was no difference. This was very, very basic. So nothing to really, raise any eyebrows. Now we're going to start getting into the plot. Dr. George Gay would then publish in 1954 his discovery of culturing a human cell line. So that was 3 years that they've already been keeping this continuous cell line alive. And Henrietta's family was only made aware of their mother's cells and their contributions to the world in the mid-1970s. All of this was going on. The polio vaccine came out, and they didn't even know. So also the book, it was written in 2010 by Rebecca Skloot. Only since the book came out that this issue and this story was really publicized. A little bit about the Gay Lab and Johns Hopkins. Again, this discovery changed the world for the better. No one is second guessing that. And we can all be thankful for what they did at this lab. John Gay noticed that the HeLa cells are able to grow in diluted adult or horse serum rather than placental cord serum. That was good because it's a lot easier to get horse serum than it is placental fetal or fetal placental cord serum. It's what it means, or it comes from what it means. They also in his lab did a lot of work with exposing cells to viruses. So he, of course, did the same thing with the HeLa cells. They were able to replenish after being exposed to the virus. Really great work being done by them. Okay, so you can see it was like the highlighting. So this is actually taken from the article from 1954. They wrote that this human malignant strain HeLa has been widely distributed throughout this country and abroad, especially for virus studies and studies of cell nutrition and special cytology. Johns Hopkins makes a note of it, that these cells, anyone that asked for these cells in the US, abroad, they were able to receive them free of charge for the better of science or to better the world.
In this article, they publish and say that the cells will belong to Henrietta Lacks.
Oh, that's on this slide right here. So the article was published in the same, again, 3 years after they discovered the cells, that in the same journal that I saw this publishment or this article, I saw 2 more papers, they're highlighted there, that use HeLa cells in their research. Like I said, 116,000 publications on PubMed. In the acknowledgement section of Gay's article, it's written there, but I'll summarize. There is no sort of acknowledgement to where the cells came from. Nowadays, in pretty much every article that I've read, it's always somewhere mentioned, okay, this biological sample came from so-and-so or whatever. And here there was no such acknowledgement. This is actually a picture that I just took from this week. I was in a presentation on Sunday about a new fax machine coming to the university. And even here, HeLa cells are still being used, despite in the world of in vitro, it's they've gone through many mutations. So but they're still being used, and that just goes to show that even on Sunday I see a paper with the HeLa cells being acknowledged. Okay, so why do we have a story here? What's really the case? The issue is that no members of the Lacks family was made aware of their mother's cells until mid-1970s. In that time period, Henrietta's children were called into Johns Hopkins for additional testing by researchers, still without anyone telling them what was going on or what happened with the cells since. No member of the Lacks family was consulted on the future of their mother's cells and further research. And as recently as 2013, researchers from the European Molecular Biology Lab published an analysis of the HeLa cells genome. It was quickly retracted, as it was a complete violation of privacy, and it was done without the permission of the family. It went over. But basically what I'm trying to say here is that the issue of informed consent isn't the main focus here. The issue is that at some point in time between when Johns Hopkins was sending out the cells for free and now, there is a lot of paychecks being cashed on the name or because of HeLa cells. And meanwhile, this family, members of the family are still living in poverty. They can't even afford health insurance in the United States.
But the scientists did the work.
The scientists did the work, and that's what I'm saying. It's a great scientific discovery, no doubt about that. The issue is and what they call, and I'll get to it in a second, unjust enrichment is the fact that Johns Hopkins says that they didn't make a dime off the cells. However, Thermo Fisher sells the cells for $2,000.
Yeah, but
If you
pay
order
for
them.
the storing them and sending them to you. Like you're basically paying for the service provider,
No,
not the actual product.
What about the patents on the research, all of
Yeah,
the,
but it's on the research because you can't patent like biology. You can't patent like a protein you're isolated because it exists in nature only if you made modifications to it. So like it's not like you can patent HeLa cells and every time you sell HeLa cells, you get like money.
How about using HeLa cells to screen for drugs?
Yeah, but like
So you're using that cell.
yeah,
Does
but
it have
that doesn't
any
matter.
value? I mean, copyright, intellectual property, something?
Yeah, but for example, we use a lot of labs, these Drupal cells, which come from a 14-year-old boy. And it's on the database, it says where it came from, there was informed consent, but like, does it really matter for
Well,
science? It
there's no
doesn't.
consent here.
You
But
know?
this is terrific discussion, but let's finish.
okay, I'm almost done. And then, no, and that's awesome because it's things that we should think about, and it's a good point. So there were things that were good things that were coming out of this story, not necessarily because of the story, because no one was really made aware of the story, but at least in 1964, finally, we have the World Medical Association's Declaration for Helsinki that was published that basically stated that there needed informed consent for participating in research and for giving biological samples. In 1974, it's just the US version of the same thing that the World Medical Association is saying. And finally, financial reparations not made from any companies, but from private donors. The family started to see some sort of reimbursements. Rebecca Skloot, the author of the book, also in 2010 founded the Henrietta Lacks Foundation. That was a foundation that received donations and they gave grants to all different people in minorities for covering health related expenses, including members of her family. Another thing is there was an HBO movie released in 2017 starring Oprah Winfrey. The members of the family were employed by HBO or the movie producers as consultants. So they also saw money there. Members of the family do talks at universities, and I think I saw like 5,000 a speech or something, but regardless, they're starting to see money. The next part in the case is Lacks versus Thermo Fisher. They put out a lawsuit against Thermo Fisher on the basis of unjust enrichment, what I pretty much summarized earlier. And they just want to give permission and to be in agreement with these companies that are supplying the cells and to receive some sort of compensation off of it. I don't know why the thing, but
Probably the aspect ratio
yeah.
of your slides is different.
Okay, so that's it.
If I
We're
buy
done.
them myself, can I grow them by myself and sell them? I mean, anyone can do it.
I mean, like, it happens because I know that like a lot of labs do that.
But this cell line is not the ATC, how is it called?
AATC can,
The database?
I think it
Well,
is though.
ATCC is a repository for cells,
Mhm,
and there is no cost.
mhm,
They just charge you for the storage, for the handling, for picking, but they don't really sell you the cells. So you can redeposit it actually cell scientifically developed. Everybody is depositing cells there, and then if you want it, you ask, and you pay a few $100s just for them to handle it. But it's not $2,000.
yeah, which
Sorry.
anyway, it's like going to a nursery.
Yeah, but the idea of it's actually a company, but it's a non-profit company. It has few subsidiaries which are for profit, but the parent company is non-profit, and it's really along the lines of open science. But this actually was established way before. Because all labs that take cell lines and then modify them by changing the genome and so on, having some mutation or whatever, there is so much work done in every lab to do that. And then if a student or a postdoc finishes, graduates in the lab, somehow after 10 years, you can find it in the freezer and it gets lost. And this is huge waste of resources. So many, many years ago, they already decided it would make sense that you have one place where every lab that wants to send cells, mutation, whatever, and they keep everything. And then you can approach them and ask, I need that particular cell line to sell it to me. They will just charge royalties. That's all. So, and I'm sure Eli is there. You can
I saw it
so
in.
there is no real cost.
But the fact that you can still go onto Thermo Fisher right now, I did it myself, and you can still
so
see.
Maybe Thermo Fisher is purer, or whatever, by a standard, or they don't do as many passages, or I don't know what, but in principle, you can get all of these cells for almost for free.
And
Anyone can ask for these or only?
Yeah, anyone.
yeah.
So we ask, I mean, we deposited once, we ask for many times.
It's not so easy to grow a cell at your home if you're thinking about it. They need many environments of.
But they do it in Nestiona. Then you can buy it in a form of a steak.
So just the last point that I do want to make is that just to give a good rep to the family isn't against making agreements. They've made agreements with the NIH about using the cells for research. It's just it's a matter.
Initially, it was not set up right.
Yeah. So that's the story.
It's terrible, and so is poverty. But it seems like you've got two stories running in parallel. There's the moral aspect, and then there's, well, if we say it's okay and get our money, then it suddenly all becomes okay.
It's not okay. It's about repairing injustices in the past.
The money's not going to achieve that.
Okay. Wait a minute. Let's first thank Han.
Thank you for your time.
Presentation is open for discussion, and this is terrific. Really, thank you, because there are so many ethical issues here. It was just handled improperly initially. Nowadays, we do get cell lines from patients, so but take some consent and it's okay. But when you don't do that, all the questions come up.
Sorry, I just have one to say because I don't.
Yeah,
think,
say it.
I just don't think that it really matters. Like the fact that she was mistreated because she was Black has nothing to do with the cell line. Like if she were white, I don't think they would have told her family. Like I think they would have done the same thing. Maybe she would have been treated better, but for the cell line, I don't think it matters. Like
Well,
No, but I
there were no
doubt-
rules. The point is,
Yeah.
there were no rules, and you're right. If it was a white patient or a Black patient, doesn't really matter. They took a biopsy, then they cultured the cells and did whatever they want with it without getting a permission.
Today we have the same key that they need to write.
Okay, but that's what we are talking about. We are talking about the consent. There was no consent.
Yeah, but there was
No, but never
law.
mind if it was white or
But
black.
maybe
Maybe
the past.
Helsinki, right? Stuff that was done 30 years ago in foreign countries, we still use that research. So we're going to say, okay, since Helsinki, anything prior to Helsinki, we have to scrap and doesn't exist, or we can't use scientifically, or we can't follow those trains of thought because that data was collected in the way that now data is morally
So I luckily, NIH was kind and came to agreement with the family. I totally agree with you when we talked about waste of resources in science. So whatever was done, and we can still use those cell lines to do some good science. But we try to do things better, right? So obviously nowadays you have to sign a consent. That's a result.
So thank you.
All right, great, thank you. Dolev.
First of all, I just want to say that I'm sorry. I'm just a bit tired. And the second thing that PowerPoint AI is awesome. It's helped me go through all the
So
preparation.
everybody had the news last week, right, about this fantastic AI software that can make art. So maybe we can have AI prepare those talks for you.
Even this was done by
That's AI.
yes.
So Donald, you invested, huh?
Okay, so today I'm going to talk about Thomas Midgley Jr., a little bit of background. He was a mechanical and chemical engineer. In 1916, Midgley began working for GM, General Motors. He was working to solve knocking in internal combustion engines. We are going to talk about this. He was a talented scientist. He received many awards, namely Priestley Medal for the American Chemistry Society, the Perkin Medal, the Willard Gibbs Medal, and the Nichols Medal. He was the director of the ACS, the American Chemical Society, for 14 years. He was a chairman of the board director for 10 years, a president of the ACS in 1944. In May 2003, he was inducted into the National Inventors Hall of Fame for his invention of ethyl gasoline and the freons. Okay, so what is engine knocking? Let's talk about how engine works and why does it knocks. Okay, so let's look at the following figure. It is useful to consider the example of a simple four-stroke cycle internal combustion engine. So the first stage, it's the intake, air and gasoline mixture is thrown to the cylinder. After that, the compression of the mixture. Then the engine ignites this vapor and exhaust. All the byproduct is driven out from the cylinder. So what is knocking? It's when some of the vapor is still left there and irregular combustion happens and makes the engine work poorly and it knocks.
You all heard backfire from a motorbike. I'm sure. It's a big. That's not.
Okay, knocking has negative effects. The presentation was all black, so I don't know. The color changed.
Yeah. So
and all the useful thing I talk about the AI. Okay.
Well, if you want, we can unshare and just open your specific.
It's okay. It's okay. It's okay. I hope the joke that I put in.
The joke, right?
Hope everything will be all right. So the negative effects of the knocking, overheating, loss of power output, waste of gasoline, because it's not efficient enough. In extreme cases, damage to the engine. Okay. To solve this knock, you need a higher compression ratios. Compression ratio is the ratio of the total volume over the compressed volume. So higher compression ratio are desired. It prohibits higher consumption compression engine. The engine will be more effective, more efficient, more powerful. Okay. To prevent this knocking, Midgley was looking. Midgley was looking for anti-clock agent. It's a material that you can add to gasoline, and he found out that many materials could lessen the effect of this knock. So it was quite literally a hunt. By trial and error, Midgley tried several materials. For example, aniline, it was not about, but it wasn't good enough because aniline had a strong smell, it oxidized with air, and there were concern about toxicity and corrosive effects on metals. The ethyl selenide was also not good enough because the ethyl telluride was better, but the ethyl telluride, you can get telluride poisoning. So telluride poisoning, if you get it, if you inhale or it comes in contact with your hand, your whole body smells out of garlic. I quote Midgley, this satanified garlic odor was so powerful that a change of clothing and a bath at the end of the day did not reduce your ability as a tellurium broadcasting station. Nor did the odor grow much weaker when several days were passed in absence from the laboratory. Okay, so after this hunt, I even heard they used lard as an anti-clock agent. Lard is pig fat. Okay, the hero of his work was tetraethyl lead or ethyl. He discovered it in 1921. Why was it so good? Just one thing. 1/14 of 1% solution of tetraethyl lead or tel or ethyl, those are the names of this material, was equivalent in knock inhibition to 1.3 aniline in corazine in some fuel. So it was very good, very efficient. It was it solved the knock. It was cheap because you use less material. You need just a small amount of it. Okay. It should have been another slide that Midgley himself said. Okay.
No, I can do this. You don't need to do this. It's all good.
המחשב שלו יפתח לך, אתה מציג שלך.
אוקיי. אז אני לא צריך? אוקיי.
No, I think I said that, no?
So this was wonderful material. He amazingly solved this problem. Oh, yes. Okay. Okay, so let's just summarize in his own word why ethyl is so good. Since there is no knocking, the engine is more efficient, so less fuel is needed. Due to its higher efficiency, less carbon monoxide will be released to the atmosphere. The motor is less prone to failure and damage, so it brings the cost of the car down. So let's continue with the timeline. In 1922, Midgley was awarded the Nichols Medal of the ACS for the discovery of ethyl. Around that year, Midgley suffered from lead poisoning. Some of the symptoms were subnormal body temperature, reduced blood pressure, digestive problem, which could be traced to his work on ethyl, and he needed 1 month to recover. many colleagues even warned Midgley about the negative effects of lead. However, despite his own health problem, Midgley did not appear to overly concerned about the health issues associated with handling and use of tetraethyl lead. So why lead is so bad? Do you guys know? Okay, just one. So let's talk about the health risk. Behavioral problems, learning deficits, lowered IQ, long time exposure to lead has been reported to cause anemia along with increased blood pressure. Severe damage to the brain and kidney in pregnant women. High exposure to lead may cause miscarriage. I believe I convinced you that lead poisoning is really difficult, really toxic. Lead is so toxic due to its ability to mimic or compete with calcium, which affects neural signaling. And some even attribute the fall of the Roman Empire to lead poisoning. The use of lead as a wine sweetener. There's a byproduct of lead that is
Where are you exposed to
in the sewer, everywhere they were using lead, everywhere.
But in the Middle Ages, after gunpowder came to Europe, they were making bullets out of lead, and they got poisoned. In fact, the word ghetto comes from Venice. That was a place where they melted lead and made, and it was so toxic that they sent the Jews to that part of Venice. And in drinks, when drink was invented, the letters were made out of lead, and people in that industry got sick. So people knew that lead was poisonous.
So as I said, this sweetener, you can get artificial sweetener from lead, and they poured it into wine. And it caused many emperors to lose their sanity. To demonstrate the harmless nature of ethyl, on October 30th of October 1924, Midgley organized a press conference. In the presence of numerous journalists, he poured tetraethyl lead over his hand, even placed a bottle and of the dangerous chemical under his nose and inhaled the vapor for 60 seconds. Then, again, quoting Midgley, I could do this every day without getting any health problem whatsoever. In saying this, Midgley consciously lied to the journalists, right? He knew all the time that lead is so poisonous. And after that, he got lead poisoning, and it took him 1 year to recover. 1 year. More cover-up. In 1925, 5 workers that were working at the tetraethyl lead ethyl factory plant, and they died 2 months after operating. Midgley responded that it cannot be lead poisoning because lead poisoning causes tripling of blood cells, lead line at the base of the teeth, stomach cramp, paralysis, and in extreme cases, death. But they got, in his own words, drop of blood pressure, drop of body temperature, reduced pulse, all those things. Delirium tremens, which is like alcohol withdrawal syndrome. So this is our guy. He also continue and say the first 3 symptoms do not indicate any danger to the patient who, if removed from proximity to tetraethyl lead, readily recover his original health within a short time. He also mentioned that sleeplessness is also curable. Again, cover-up, over cover-up all the time. I want to talk about his death. I think it's important. In 1940, Midgley contracted polio. We talked about polio. Yes. It's a shame that how we say it?
Pandemic
Hella?
right now.
HeLa cells. He created his own pulley system to get out of bed. I guess he wasn't paralyzed because he was an older man. He wasn't a child. And in 1944, he entangled in this device and he stroked. He strangled, right? Yes. What is the outcome of all this story? It was always a concern that using this fuel is bad. Around the 60s, environmental, sorry about that. The environmental movement advocated to stop the usage of ethyl.
I knew from the 1920s until, well, are you saying it when they stopped?
They stopped in the US at 1995.
1995.
And in Europe, 2000. And today we are still using.
Years of usage.
Yes.
When I moved to the US in 1989, we would still buy leaded fuel. After a few years, they stopped, but it was all over. And they knew already in the 1920s, but it's paid.
Yes. Where was I? Today, right, thank you. Today, mini aircrafts, right? How do you say? מטוסים קטנים, קלים. They're still using that, yes.
This fuel?
Huh?
They're using this fuel?
Right,
Oh.
yes.
It's an additive to fuel. So you used to have, you go to the gas station, in the 1990s, you had leaded fuel and unleaded fuel. Then in 95, they stopped. You had only unleaded fuel. But you had the choice of buying leaded or unleaded. The addition of this additive basically spikes up the octane of the fuel and the engine runs better. So without really purifying the fuel for higher degree, you just add this additive and you are at high degree. That's ideal. But you have all this poison coming out.
Bless you. So legislation came to be around 1970 with the Clean Air Act. Another reason that leaded fuel, we declined using this additive to fuel is because the Clean Air Act made, I believe, General Motors to add a catalyst converter. This apparatus just so happened, this apparatus reduced pollutants, and it just so happened to be that the catalyst could not tolerate leaded gasoline. So just another reason. Okay, as we said, around 95, it was banned in the US, 2000 in Europe. We can see how the effects of removing lead from gasoline on blood levels in the US between 75 to 80, 1975 to 1980. I found an article that said preschool age children in the late 90s had IQs that were on average 2.2 to 4.7 points higher than they would have been if they had the blood lead distribution observed among the US. So lead actually affects IQ of the population. When IQ is low, you can convince yourself that it's less profitable. The people are more dumb. So let's talk about just another note about another invention. The Freon. Midgley successfully developed a cheaper and safer refrigerators. He found dichloro-difluoromethane, which was the first CFC that was a better refrigerant. And as we all know, CFC caused the hole in the ozone layer. And again, as the showman he was in 1930, immediately inhaled a big amount of Freon 12 and then blew out a lit candle to show the ACS that CFC was absolutely non-toxic and non-flammable. So this is the end of my presentation. What were his motive? Is it pure greed? It was, well, he was a talented scientist. He won all those medals, all those prizes. Why? He knew it was so toxic.
Does that remind you of other stories like this? Where money plays a big role, and because of money, people are being poisoned.
I think that once he realized he was mistaken, or he realized there was another effect, it was his ego that prevented him from admitting his mistake.
Well, I think it's much more than this.
He was also working
It
for
took
General
about 100
Motors.
years for the tobacco industry, and it took about 80 years here.
No,
The capital,
about him.
the capitalist forces,
Yeah.
you know, that was billions of dollars, you know, that additive. And you go to Washington and you lobby and you try to convince everybody that it's fine. You know, the famous case of all the tobacco CEOs coming to Washington to testify in front of the Senate. And the plain lie under oath to okay, it's money, right? And eventually they paid dearly for this. Lead in fuel is the same story.
He did not knew that freon would cause the hole in the ozone layer. So
yeah,
this is
time to find out.
So I wanted to note that because he really did. He was a good scientist. He was looking to solve problems. He did that.
And the ill effect of nicotine or lead, you discovered this only many years later. But the question is, how nimble are you to really, once you find the top issues, and to stop it? But there is such big inertia, it's very hard to stop.
But this is not the case.
He knew that lead is toxic. It was well known.
Was it pushed to publish and to develop it further?
Maybe General Motors were another.
Yeah, probably there was some big guys behind.
Yeah. They even called it ethyl to how they say it.
The fact that
it's lead, right? Yes. So. Okay.
Great. Thank you. Last speaker is. So we missed some of the AI, right?
Yes.
Sarah?
Yeah, it's me.
Okay, so let's try to get you to share your screen. Just a minute. So you can share already, right?
Yeah, I'm already sharing.
Just a minute. I'm sorry, I thought it would be a good idea to have everything on one PowerPoint. Okay. Sarah, we are ready for you. Go ahead.
All right. Hello, everyone. My name is Sarah Levin. I don't know if you can see me, but
Yes,
I
we
am
can.
indeed human. All right. So far, people talked to you about some scandals and about mainly people reacting to failed experiments and faking the result, or just faking the result in general. I'm going to talk to you about a good hero story, for example. And basically, I'm going to talk to you about the Nobel Prize. Can you see my pointer? Because I might point.
Yes, we can.
All right. I'm gonna talk to you about the Nobel lecture of 2006 about the cosmic microwave background radiation anisotropy. If any of those words are scary, I'm gonna explain them. Don't worry about it. But before we start, we have to go way back to the 1920s, when two giants of astrophysics came up with two different theories. First of all, there's Sir James Jean, an English physicist and mathematician. He concluded from the recent published data of nebulas forming on the rim of our observable universe that matter continuously is created in our universe. And therefore, he created a subject called steady state theory, which basically says exactly like that. Nebulas form from extra dimensions that we can see. And that's how all the stars form, and etc., etc. On the other hand, we have John Lemaitre, I hope I said his name right, a Belgian astronomer, cosmologist, and a priest. He was inspired by a Hubble observation of the expanding universe and Albert Einstein's theory of relativity. And from those two, he concluded a proposed theory of the Big Bang theory. It wasn't the first time someone proposed a single catastrophic event for the creation of the universe, but it was the first time where a super atom model existed, and this is the model that we use until today. Now, when I said cosmic microwave background radiation, or for the rest of this presentation, I'm going to just say CMB for short. I'm talking about a radiation for a specific event in time. Basically, around 14 billion years ago, some sort of cataclysmic event happened, and which we call now the Big Bang, and everything was dense and hot, and it was so hot and dense that no light could escape or move around at all. After about 380 million years, the universe expanded rapidly and cooled down rapidly. It cooled down enough for light to escape in a big flash. This is exactly what we are looking for, that escape. Now, the first discovery of cosmic background radiation actually happened by complete mistake. It was first discovered in June 1st, 1968 by the two scientists, Erno Penzias and Robert Wilson.
He was the director of AT&T Bell Labs.
Yeah, I tried many times to say his name right. I always fail. All right, those two tried to measure low frequency radio waves from faraway galaxies when they encountered some sort of noise in their measurements. They first checked their equipment, so the noise stayed there. They even assumed that pigeons kept dirtying their machine, and they actually caught many pigeons in the area trying to keep it clean, but the noise was still there. After a lot of playing around, trying to make this noise disappear, they actually concluded that this noise that they saw was the microwave background radiation that people were starting to think about at this time. They calculated that the microwave background radiation was 5 Kelvin, which now we know it's very way off, about a factor of 2 off from the actual radiation. Now, this research won them a Nobel Prize in 1978 for the following contributions to the field of science. It basically was the first big in quotes proof of the Big Bang theory. It gave us a certain level of estimation of how much our universe expanded. It helped us build the story of our universe, and it expanded and basically created the much of the field of cosmology to this day. But even though all of this contribution and the Nobel Prize, most of the science community did not accept the result and the research. They claimed a few different parameters could have came into play when this research was published. First of all, again, the research was at 1968, very low grade equipment. People contributed to electric noise, stuff like that. Secondly, absorption by the atmosphere and Thomson scattering by the atmosphere, mostly in those wavelengths, made people skeptic about how valid those results are. Maybe it can be like a scattering from a radio station nearby. Another argument people made is that the Earth itself is a very hot body, black body, and it can emit black body radiation. If somebody is not aware what it is, it will come up again, so please ask. The system itself couldn't be kept cool and could be considered as some sort of black body radiation source. Lastly, they try to compare the radiation to the measure to the sky with a black body source of their own, which they couldn't keep cool because, again, a lack of temperature. Lastly, the last point, which I will explain later, is wrong approximation of the anisotropy of the CMB. Anisotropy basically means that if we look at different points of the sky, we're going to see different measurement. It's basically a measurement of how ununiform the radiation is in our sky. In their research, they assumed that the entire CMB radiation was completely uniform, which we later found out that it's not. Okay, let's talk about one of the first graph in the Nobel lecture that came up. This is a graph of the history of humanity trying to measure cosmic background radiation. The x-axis is just the wave number. You can take each of them and basically say, okay, that's one frequency, another, and another. And the y-axis, it's what temperature should the black body have if we were to measure its intensity. Basically, the intensity that we measure in the sky, we compare it to black body radiation in that temperature. The first two measurements here, those are the two measurements that won them the Nobel Prize in 1978. And we can see the error bar show us about an error of 25–30%, which is for many people unacceptable error bar. One of our Nobel Prize winners, which I'm going to talk about, said it's like hearing a whisper at the hall while in a beach party. Now, after all this, after everything, after all the beginning, I'm going to talk finally about the actual Nobel Prize. Our two Nobel Prize winners, John C. Mather and George F. Smoot, came up with an experiment for John Mather's doctoral thesis to try to measure it with some new equipment on the ground. But as measurement before them failed, they also didn't get any usable data on the ground and scrapped it. They only after a few months of trying to get data over and over again and failing, they understood that they only have one solution. They should go into space. They figured out that was the answer to the problem, and in space they could get a much more accurate and more definite solution. Just lucky for them, NASA just came up with the 1974 Explorer satellite project with 150 suggestions. 3 were accepted, which the one we care about is the Kobe proposal. And then when all was good, they came up with another setback. In 1986, 26th of January, the satellite had exploded from a faulty O-ring, which regulated temperature. But not all is lost. There was still a smaller Kobe Delta satellite, which required them to lose about 50% of the weight of the system. The satellite was launched and set into orbit in the middle of 1989. Now let's talk about the satellite itself. Satellite itself had three main systems: the DIRBE, which I'm not going to talk about in this presentation, the FIRAS, and the most important one, the one that we should really pay attention to, the DMR system. So let's talk about the less important one, the FIRS. The FIRS is basically just an interferometer, if you know what it is, which has two ports, one aimed at the sky, and one has some sort of black body with a very stable temperature in order to compare the sky radiation and the black body radiation. The point of this experiment, the main point was to see the entire spectrum of the cosmic background radiation that comes from space and identify the temperature of the CMB itself. You can also see they also try to test with it some large fluctuation in form of dipole due to the motion of Earth and the motion of the spaceship itself. And lastly, for us, they try to limit the spatial variation of CMB spectrum. It's almost exactly the same as what I said before, just a little different. I'm not going to go very much more into it. It also had some other experiments in mind when there's a system everyone wants a piece, but I'm not going to really talk about them because they're not relevant to us. Now let's talk about the FIRS result. This is one of the graphs that the FIRS result tested. It measured the sky for about 9 minutes, and it came up with this. The x-axis is again the wave number, and the y-axis is how much the brightness. Basically, for our purpose, how much power we see. What's the flux? The rectangles, the black rectangles, are the actual measurements, and the line, the black line, is comparing the black body radiation with our measurement. The black line is the spectrum of a black body, and the boxes are our measurements. And this is the same graph, but converted from intensity to black body temperature. And we see that overall we have about 1% error bar in the main peak of our radiation, and which is about 2.726. which we can see is half the temperature of what we saw before in the earlier Nobel Prize winning. Now for us, the DMR. The DMR is basically a set of radiometers. They measure it. They have 6 different set of tubes. Each tube has an opening of 7 degrees, and each tube is separated by 6 degrees. Like that, you can take pictures of the entire sky at different angles and map the entire angular scale anisotropy. It ran at 3 different wavelengths just to make a better test, and it attempted to show us the evolution of the universe, and try to prove that the CMB is not like a camera flash, but more like has small fluctuation where the galaxies will form and stars will form there. All right, now let's go over the result of the DMR. First of all, we have radiation in the background temperature measured by the FIRS compared compared to DMR results. We have a certain uniformity in the 2.728 Kelvin temperature. If we take small fluctuations in the temperature, we start to see the dipole that was also measured in the FIRS system. And the last picture is the most important one. If we take a very small fluctuation in our compared temperature, we see some sort of anisotropy itself. And the red line and the big red dot, our galaxies, the red line is our galaxy, the Milky Way. Now we have this is the same picture as before without all the mess of the Milky Way and the other galaxies. And this shows us the birthing point of our modern universe. Now, for us to understand those results in a much better way, we have to talk about a few different effects. First of all is redshift, and specifically redshift in an expanding universe. If we look at it from relativity or cosmology, first of all, redshift or Doppler effect is an effect when a source is moving away from you, so we see lower frequency or higher wavelength. In an expanding universe, meaning relativity or cosmology side of it, we actually have an effect that is almost the same as the Doppler effect, but it comes from different source. I'm not going to go very deep into it, but we can summarize the Hubble's law in the following equation. When we have the observed wavelength divided by the actual emitted wavelength, it will give us the same ratio as the expansion of the universe itself. Lastly, we have to learn to understand the Wien's law, which basically tells us for every temperature has a maximum wavelength, which is the strongest, given to us by this equation right here. With all of this knowledge, we can calculate the expansion of the universe, which was one of the main point of this research. Some assumption and calculation were made to show that the temperature of the universe at the beginning was about 10 million Kelvin, and therefore we can see that the wavelength was about 0.29 nanometers. And if we use Hubble law from what I showed before with the redshift, we can see that our universe expanded by about 3.7 million times, or in volume about 1.3 times 10 to the 13. Now I wanted to talk about the physics because I love the physics, but it's not the main object. So I'm just going to go straight to the discussion for this entire story. First of all, if your research wasn't accepted by the science community, what would you do? Would you stop with the research, or would you push on even though you get all this backlash? Secondly, does preliminary models should receive government funding? In this case, in the form of a project in the major satellite event. And lastly, if you reach unexpected result, would you call the experiment a failure or a success? That's it.
Great, thank you.
Okay.
Oops. I think you can unshare.
All right.
Okay, great. So this paper is open for discussion. Anybody has anything to say? Well, good papers are good papers, so it's very hard to argue with them. And we all want to have papers. Yes.
The main point of my talk was basically about this entire subject was not really readily accepted in the science community. Maybe I didn't. And
I think we should have spent maybe a slide or two on that fact. And it's oftentimes that some unexpected but very important result gets very strong resistance from.
I love this story because it was basically
who cannot really think and push back. And
Galileo is the best example for that.
Sorry?
Galileo is the best example for that.
Like it's from
Yeah, yes, there are many, of course. Yeah, of course. Ether, right? And there are examples, I think, in every field. But Sam, really, if that was your main point, I think you should have added a slide or two just talking about and describing that resistance. I guess there were some. Were there any papers kind of arguing against?
Yeah, but I formed my presentation to be 15 minutes because I thought that was the time limit.
That's good. But I would actually be very interested to know, I mean, to see the title of the paper that would say, you know, these guys are morons and they don't know what they're doing, right? So
okay.
in general, when things like that happen, then you can start to have discussions in the journal where you send responses back and forth, and eventually, you know, the paper is going out for the jury, and over time, there is some conclusion who is right. So yeah, I think that's a good example for a case where initially there was a big resistance. Anything else?
Thank you.
What was the origin of the noise that caused the anisotropy? Do we have any ideas?
I can't really hear.
What
anything.
was the reason for the anisotropy? Could they figure it out?
Oh yeah, basically the anisotropy came from there's a few different parameters. First of all, if you are familiar with the conservation of energy related to symmetry in time, basically the universe didn't have it, and the pockets of energy could appear and disappear, and this sort of came from an uneven formation of mass and stuff like that. And secondly, it just I didn't go too deep into this field because it's not my field. Secondly, what I saw was I forgot for a second, but the first reason is the main one.
Okay, other comments? So if no more comments, again, let me remind you that next week we'll go back to fully remote format. Try to keep your time to 20 minutes. It's exhausting. From now until the end of the semester, we have 4 presentations each time. And that's a little bit exhausting. So try to keep 20 minutes. I think you can really get the main idea through in 20 minutes, a few minutes for questions. I really love the discussions after each one of these. You all did fantastic jobs in finding interesting stories to tell. That's what the whole idea was. So that's great. All right. Thank you very much and good evening. And we'll see you online next week. Bye-bye, everybody.
Bye-bye.
Bye.